paper of the day is The Part-Time Parliament. So this paper is about Paxos. It's a consensus algorithm known as one of the most efficient and elegant consensus algorithms. If you stay close to the field of distributed systems, you'll hear about this algorithm over and over again. And this paper in particular is a pretty hard paper to read and understand. So here's a brief history. Paxos was developed by Leslie Lamport of the Lamport clock fame. A fault-tolerant file system called Echo was built at SRC in the late 80s. The builders claimed that it would maintain consistency despite any number of non-Byzantine failures and would make progress if any majority of the processors were working. Now, Lamport decided that what they were trying to do was impossible and set out to prove it. Instead, he discovered the Paxos algorithm. He decided to cast the algorithm in terms of a parliament on an ancient Greek island called Paxos. So, on a high level, the paper abstract reads as follows. The recent archaeological discoveries on the island of Paxos reveal that the parliament functioned despite the peripatetic propensity of part-time legislators. The legislators maintained consistent copies of the parliamentary record despite their frequent forays from the chamber and the forgetfulness of their messengers. The Paxos Parliament's protocol provides a new way of implementing the state machine approach to the design of distributed systems. It's hard to understand paper and super hard to follow the story. Here is some bit of history again. So people thought Paxos was a joke. Maybe it was the very obscure nature of the paper and its storytelling. Lamport published it 8 years after it was written in 1990. The title is The Part-Time Parliament. People did not understand the paper, and still they don't. I think most of the people, they don't. So Lamport gave up and wrote another paper that explains Paxos in simple English, called Paxos Made Simple. It's still not the easiest algorithm to understand, unfortunately. People have written papers and lectures notes to explain Paxos Made Simple, like Paxos Made Moderately Complex, Paxos Made Practical, etc. So, looking at Paxos assumptions and goals. So the assumptions are the network is asynchronous with message delays. Messages can be lost or duplicated but not corrupted. Processes can crash. Processes are non-Byzantine, that is only crash stop. Processes have permanent storage. Processes can propose values. Goal. Every process agrees on a value from the set of proposed values. Desired properties. Safety. Only a value that has been proposed can be chosen. Only a single value is chosen. A process never learns that a value has been chosen unless it has actually been chosen. Liveness property. Some proposed value is eventually chosen. If a value is chosen, a process eventually earns it. There are 3 roles. Proposer, processes that propose values, acceptors, processes that accept values. Considering a value is a candidate for consensus. Majority acceptance, picking the value, and learners, processes that learn the outcome. Roles of a process. In reality, a process can inhabit any combination of roles. Important requirements. The protocol should work under process failures with delayed and lost messages. Consensus is reached by a majority. Example, a replicated state machine. All replicas agree on the order of execution for concurrent transactions. All replicas assume all roles, that is, they can propose, accept, and learn. Here is the protocol overview. A proposal must have an ID, since there is a multiple. So it goes like proposal number and value, that is NP. The proposal number is strictly increasing and globally unique across all proposals. There should be no tie. And then there are 3 phases. Prepare phase, a proposer learns previously accepted proposals from the acceptors. Propose phase, a proposer sends out a proposal. And learn phase, learners learn the outcome. Rough description of the proposers. Before a proposer proposes a value, it will ask the acceptors if there is already any proposed value. If there is, the proposer will propose the same value rather than proposing another value. Even with the multiple concurrent proposals, each proposed value will be the same. The behavior is altruistic. The goal is to reach consensus rather than making sure that my value is chosen. Rough description of the acceptors. The goal of acceptors is to accept the highest number proposal from any proposer and accept tries to accept a value v with the highest proposal number n. Rough description of learners is that all learners are passive and wait for the outcome. So here is the overall summary. Paxos is a consensus algorithm. It handles crash stop failures f as long as it's less than n by 2. There are 3 phases. Phase 1 is prepare, which is based on request replied. Second is accept, based on request and reply. And the third one is learning of the chosen value.